this is a review of the 2014-2015 chemical reactions test. Okay, so first and foremost, the place most people lost their points was in going over the equations on the last page. Okay, so these are the things that you have to know. These are the most common mistakes. These are how to solve these types of problems. Okay, so first and foremost, the combustion of methane gas. A combustion equation looks the same for every time you do it at the end. It's going to start with O2, and it's going to end with CO2 and H2O. Okay? That is the same for every combustion equation. So when you see combustion of methane gas, that's what you've got to do. Okay? Additionally, use the test to help you. This exact equation was on your test. You could have gone back and found it. Okay? So you can always use the test to help you. So here we have the combustion of methane gas. CH4 plus O2 goes to CO2 and H2O. Always the products of methane gas and of combustion, and O2 is always a reactant. Okay. Some of you had forgot about O2 as a reactant, and then you had this, and it's like, where do those oxygens come from? Okay, so make sure that you can balance it, and you're in somewhere makes some sense. Okay, and then when you balance it, it looks like that. All right. Okay, so aluminum bromide and chlorine gas react to form aluminum chloride and bromine gas. Ands are your plus signs. Reactive form is your arrow. Aluminum bromide. Aluminum, look up its oxidation states. +3, bromine is -1. Chlorine gas, Hober-Finkel is Cl2. Arrow, aluminum chloride, Al, look up its oxidation state. Chlorine is -1. And bromine gas, Hober-Finkel, is Br2. Okay? I don't have to do anything with bromine or chlorine gas, and then I flip-flop. I have Br3 and AlCl3. Okay? So, write out the formulas, flip-flop them to get the proper ones, and then go back and balance it. Okay? So I need a 2 here, a 3 here, a 2 here, and a 3 here. I'm skipping over the balancing part because most of you know how to balance equations quite well. But if you come see me if you have more questions on it. Okay? All right. For the most part, you guys did pretty well on the word equations. Let's talk about these. Okay? Predict the product. Now, I have 2 double replacement and 2 single replacement. These are my singles, and these are my doubles. For double replacement reactions, the first thing you do is find your polyatomic ions and put them in parentheses. In this case, they both are. Okay, I'm looking at 3 and 4. Let's do 3 first. Then I take the first part, the Na and the Ca, and I rewrite them. So here's Na plus Ca. Then I drop all the subscripts and I switch the partners of I switch their partners. So my Na ends up with OH, and my Ca ends up with Br. Notice I did not bring that 2 over, okay? That 2 comes from the flip-flop of that proper formula on the reactant side. I need to find it on the product side. Now I need to look up my oxidation states. Sodium's +1, hydroxide's -1. Hydroxide is on table E. It is a polyatomic ion. Calcium is +2, bromine's -1. Flip-flop them. The 2 comes here, the 1 goes there, 1, 1. I'm all set. Okay. Next step is to balance. I have 2 bromines. Let's put a 2 here. 2 hydroxides. I'll put a 2 here, and I'm balanced. Last step is it's double replacement, so I look at table F. Okay? I need to look and see if either of these are insoluble. First and foremost, I see that I have a sodium. Sodium is always soluble, so you never, ever circle anything that's got sodium in it. Okay? Now I look at CaBr2. Bromine is usually soluble, except when it's with silver, lead, or mercury. Calcium is not silver, lead, or mercury, so this is soluble too. That means there's no precipitate here. No solid, that means there's no no reaction. So I went through all that work for nothing. All right. Next, same double replacement. Polyatomic ion in parentheses. Rewrite the first ones. Oh, I see a sodium again. Remember, sodium's always soluble, so I can't circle whatever ends up with that. I'm going to drop the subscripts. I'm going to drop that 2, switch the partners. The I goes with lead, and the NO3 with sodium. Now I look up oxidation states. Lead on the left, on the reactant side, if I reverse my flip-flop, lead is +2, so lead is +2 here, doesn't change. I is -1, sodium is +1, and nitrate is -1. Flip-flop them. The ones cancel out, PbI2. All right. Like I said before we started this problem, sodium is always soluble. Oh, I should balance it first too, huh? So I know that when I look at table F, I'm not going to circle that thing. Nitrate's always soluble as well, okay? Let's take a look at the halide, and then I'll balance it afterwards. Iodine is soluble unless it's with silver, mercury, or lead. In this case, we're with lead, so we circle this. This is your solid, insoluble, okay? If I were to balance this, I would put a 2, let's see, a 2 here and a 2 here. All right. That's double replacement. You have to go through that same process every time, all right, in order to properly balance and write your formulas, okay? Every time you write a formula, you need to go through and write, and flip-flop them. Look up oxidation states and flip-flop, okay? Now, this is single replacement, so we're going to look at table J. Table J is nice because we can look at it at the beginning to see if we can actually have to do anything. So if we're looking at number 5, I have fluorine is alone. Fluorine is trying to replace who? Metals replace metals generally. Non-metals replace non-metals, okay? Generally. The exception to that is hydrogen. Hydrogen behaves like a metal, okay? That's why hydrogen's on the left of the periodic table. So, fluorine here is trying to replace somebody. I'm going to look at table J and see that fluorine is in the same column as chlorine, okay? These are both non-metals, okay? Fluorine is in the same column as chlorine. Fluorine is above chlorine, so fluorine can take chlorine's date. The date is sodium. So that means that sodium is going to end up with fluorine, and chlorine is going to end up alone. Okay, so that's if you have something alone, in the non-metal column. All right, let's go through and finish this. Let's write our formula. Sodium +1, fluorine's -1. Flip, flip, 1 and 1. Cl is just Cl, right? No, it's not. It's a Hober-Finkel. That means it's Cl2 when it's by itself. Now we double check. Balance is a 2 here and a 2 here, and we are all set. Now we look at table J for number 6, okay? I have lithium alone trying to take cobalt's date, okay? Lithium replaces cobalt because they're in the same column. So that means that cobalt is left alone. Lithium is cool enough to do that. Lithium's above cobalt, so lithium can take cobalt's date. And lithium ends up with bromine. Look up your oxidation states. CO is not a Hober-Finkel, so it's not CO2, it's just CO. Li is +1, Br is -1. Flip, flip, 0, 1 and 1, cancel out. I gotta rewrite that. Now you have to balance it. Okay, I've got 4 bromines here, 1 bromine here, so I need a 4 and a 4, and it's balanced. Okay, that's how you do the back page of this exothermic reactions. This is a copy of the test. You should have the answers of the ones that you got wrong. Some of the ones that were most commonly missed. Let's talk about those, and then we'll be all set. Let's see. Where is that example? Number 15 up here was a very commonly missed one. kcal is heat. The only other thing you'll see in a chemical reaction generally is heat. So these are your reactants. These are your products. Okay? Your reactants form your products. Your reactants produce your products. So in this case, I produce heat. Heat is a product. It is produced. That means it's exothermic. Okay? And energy is released. If the energy was absorbed, it would go in over here, but it's coming out. So energy is not absorbed, and it's exothermic. Okay? That's important. Let's read a little deeper into this question. Why is it exothermic? Because I'm forming a bond. Okay? I'm forming a bond. Remember that forming bonds is exothermic. It releases energy. Breaking bonds, like when I broke the pencil, is endothermic. I put energy in. Okay? This is forming a bond. That's another way you could determine if it's exo or endothermic. There's a lot of versions of this. There's a couple versions of this question that we'll talk about. Finally, additionally, here, this was a little bit of a review question. At SCP, 4 liters of gas contain the same number of molecules as 4 liters of gas. Same temp, pressure, volume, same number of moles, same number of particles. Okay? That's why number 18, it might be a different number if you have a different version, but that's why number 18 is 1. All right, let's keep looking. Where else do I want to go? Number 21 and number 22. 21. What occurs as 2 atoms of fluorine combine to become a molecule of fluorine? Here are my 2 atoms of fluorine combining to become a molecule of fluorine. Atom, atom, molecule. Am I forming a bond or breaking a bond? It clearly looks like I am forming a bond. Okay, so it's not 1 or 2. And I highly suggest you cross off answers to questions that you know are wrong. Okay, because that'll help you identify. We know a bond is formed. Okay? Is energy released or absorbed? Forming bonds is exothermic, releases energy. I put energy in to break a bond. I have to force these guys apart, so energy goes in to break them that way. Does not go in when you form them, okay? Forming bonds is exothermic. That was the most commonly missed piece here. Number 22. Which 2 solutions, when mixed together, will undergo a double replacement reaction and form a white solid substance? Okay. These are your reactants. So, when you're forming products, you have to, you don't really care about the proper formulas here. You just have to react them. What's going to happen? If I have KCl and LiCl switching places, like a double replacement reaction, I have K and Li, and the Cl's switch. Guess what? I still have LiCl and KCl. So that's not going to do it. If they're both aqueous, that's not going to do it. NaCl and LiNO switch NO3, switch their partners. I have NaNO3 and LiCl. Na and Li are both group 1, so they're always soluble. I'm looking for the insoluble piece here. All right. If you look at 3 and 4, they both have group 1 elements in both of them. So that means that no matter how they switch, they're always going to be soluble. If we look at number 2, when I switch and I have Na and goes with NO3 right here, when I switch, it's going to still be with NO3, okay? And Na is always soluble. Ag is sometimes insoluble, but nitrates are always soluble too, so it's definitely not number 2. Process of elimination gives me number 1. However, let's prove it. So I have K that ends up with NO3. Potassium is soluble and nitrate is soluble. And I have Ag that ends up with Cl. Cl is soluble except when it's with silver, mercury, or lead. What are we with here? Silver. So that's your insoluble. That's how you do number 22. All right. Again, number 24. To break a chemical bond, energy must be, you cannot release, you cannot destroy or produce, but to break a bond, you absorb energy, like when I broke the pencil. Okay? Number 27, remember that you have masses. You don't have to go into moles, but you know that 8 grams of hydrogen reacts with 64 grams of oxygen. How many grams of water? Okay, so you just kind of add those together and you get 72. And I'd say those are probably the most commonly missed questions. Again, if your heat comes out, if it's a product, it's produced, therefore this is exothermic, okay? And a number of you told me that the coefficient oxygen should be, I believe you told me 3. I could be totally wrong. That should be, yes, so it should be 3. And then when you get number 3, you didn't account for the 3 there, okay? Make sure that you need a full balanced equation before you do a mole-to-mole ratio. All right, you are all set.